All right, good morning, everyone. I think we'll get started, and I'm sure we'll have a few more people trickling in as we get going here, but we'll start with some housekeeping information and get going. So my name is Steve Kalina. I'm the president and CEO of the Minnesota Precision Manufacturing Association, and I think today is one of those days where it's probably best that we're on Zoom, although we'd rather be back in person as soon as we can. So appreciate you joining us. I want to share some quick updates within MPMA before we get started. I want to welcome our newest members, Ayers and Ayers, Master Fluid Solutions, World Connect Energy Solutions, Trans World Business Advisors of Minnesota, and BusyWeb. And a shout out to our new 2021 annual sponsors. We're getting everything finalized with them. So you'll be seeing their names pop up on our Cycle Times emails, on our web presentations, on our website. So please watch for those sponsors and please you get a chance to thank them for what they do for MPMA and hopefully do business with them at some point. They are a big part of what MPMA makes MPMA work. Some activities we have going on and coming up soon. We've got a food drive going on the month of January. So if your company is interested in participating, you can go to mpma.com on our events page. There's a flyer you can download there and just post it out in your shop. And basically, we're just trying to coordinate everyone doing it at the same time so you can share information and updates with MPMA, pictures. We'll get it out on social media and kind of celebrate what the members are doing. January 26th, we've got what we call a coffee chat, so kind of a small group interactive session with LB Carlson on the new COVID relief bill and the new PPP guidance. So it'll be very timely, and they'll be able to dig in and deal with things, kind of on an individual basis. So look for that information here, and hopefully you can join in for that. And February 9th, we've got a program on cybersecurity for Department of Defense contracts and the new CMMC requirements. So companies that are going through that right now are probably ripping out the rest of their hair trying to figure things out. So Cyber9's company specializing in cybersecurity is going to be able to help solve some of those issues. And on February 25th, we've got a program with CBiz on exit strategies and business transitional planning. And February 1st is a deadline for any advertising for our March-April journal of our magazine. So if you're interested in any advertising, please reach out soon in the next couple of weeks. So without further ado, we'll move on to our presentation. If you have any questions throughout the program, please use the chat log, and then we'll have a Q&A session at the end. So feel free to plug in your questions there. So I've had the pleasure of visiting Diversified Plastics several times, and including for a presentation on carbons technology, and also to see Diversified's beautiful acceleration station, a very impressive facility. So coming from an injection molding background myself, I can say Diversified is a very impressive company and doing some amazing things. So it's a great facility, and they make a lot of complex, impressive products and a lot of great people there. So. And over the past couple of years, I've gotten to know Kevin Hogan, the CEO, quite well, and he's a very impressive leader and an innovator in the industry. So I'm going to now hand it over to Kevin to introduce Diversified and our topic for the day. So Kevin, go ahead.
Great. Well, thanks, Steve, and glad we could participate in the webinar today, and glad to be a member of MPMA. So it's all good. Gonna let the music go through here. There we go. So thank you. What you're going to hear today is, as Steve alluded to, our specific carbon technologies that we've incorporated into a part of our business called Acceleration Station. You're going to hear a little bit from me, and then the vast majority of the content is going to be from AJ Frizzell, our technical support engineer, who really is driving things within the Acceleration Station using carbon technology. So I'm going to cover just a couple of quick things regarding DPI just to lay the groundwork, and then AJ will take it from there. So AJ, if you could go to the next slide. Great. So a little bit about Diversified. Steve alluded to a Minnesota-based company, obviously. We're a custom injection molder. We have two facilities, one in Brooklyn Park here, and then through an acquisition, a facility of another custom molder in Vista, California, which is just near San Diego. You can see on the screen almost 80,000 square feet between the two facilities, clean room technology in our Minnesota facilities, also certification with ISO 9001, 1345, FDA, et cetera. And even though medical is a large part of our business, we participate in a number of other industries, if you will. The other thing we like to highlight is that Diversified is an ESOP. So employees own 100% of the company. And in Minnesota, there tends to be a higher predominance of ESOPs, but it's still a kind of a unique structure. So it's been an ESOP since 2011. And the employees, definitely have a piece of the pie, if you will, and that does make a difference. So AJ, if we can go to the next slide. And again, as I mentioned, custom plastic injection molding has been the legacy business that we have here. But 2 years ago, we brought in carbon DLS additive manufacturing technology. And we incorporated it in what we termed the acceleration station. So that's our go-to-market approach for our additive manufacturing section. And a key tagline that we have, key message for acceleration station is fastest path to market. So it ties very well into the theme for today's, powering product innovation. And AJ will take you through that in a moment here. And as I said, medical device is our primary sector, but we are very involved in a number of industrial sectors, as well as aerospace, defense, and electronics. So the next slide is going to be a quick video of Diversified Plastics. And when we get through that, then AJ will pick up and take you through specifically the carbon DLS technology. So thanks.
All right, thank you, Kevin, and hello, everybody. Again, my name is AJ Frizzell, technical support engineer here at Diversified Plastics. I'm going to give a brief overview of our relationship with carbon and then move into the technology, and we'll end up with a live demo in our lab here. So at the end of 2018, DPI became the first plastic injection molder to join the carbon production network. Most recently, Carbon awarded us with the distinction of being one of their premier partners. And carbon DLS, our carbon digital light synthesis additive manufacturing, is a cornerstone of our acceleration station, which provides customers with the fastest path to market. In addition to DLS, our acceleration station services include design for additive manufacturing, inspection under our stringent quality system, clean room assembling and packaging, as well as lot traceability. Before we dive into the design for additive manufacturing, I'm going to provide you with a little information on the carbon digital light synthesis process. Carbon DLS fuses light and oxygen to provide parts from liquid resins. It economically produces end-use parts in days instead of weeks. Carbon DLS process requires no tooling and manufactures parts that most conventional 3D printing and manufacturing technologies cannot. Using this technology, parts can be manufactured from a wide selection of materials. I have another video coming up here which will show the carbon DLS manufacturing in action and provides an overview of its benefits. Awesome. Now that you hopefully have a little understanding of what the carbon DLS additive manufacturing process is, I always like to discuss additive manufacturing design and how it relates to carbon DLS. Not all parts are ideal for the carbon DLS process or traditional 3D manufacturing. Many parts are better suited for manufacturing using plastic injection molding and other conventional manufacturing methods. But some of the things that really carbon DLS really excels at is limiting components together. We can take an assembly and fuse it down into one part, which really helps us on assembly time and the actual manufacturing of many different parts. Because carbon DLS eliminates the need for tooling, the process from design to production and use parts is much faster and more economical. And we allow rapid prototyping, faster design iterations with multiple revisions of the same part being printed at the same time, so we can really compare the different rev levels of parts. Available for decades, traditional 3D printing allows engineers to design more complex geometries. However, high volume and end-use part production has not been practical due to the slow printing speeds and limited material selection. Additionally, most 3D printed parts are built in layers that must adhere to one another during the printing process. And under specific thermal stress and part orientation, these layers, some geometries may fall, separate, or fail entirely. And that's where carbon DLS really excels. We can produce complex lattices, we can do surface textures. We really have a lot of differentiation between traditional FDM manufacturing. And this technology really isn't just for prototyping. It delivers small to large volume production of end-use parts using a wide range of materials with diverse mechanical properties. And thanks to the design flexibility of carbon, engineers are also able to boost quality, strength, stiffness, heat dissipation, and performance. One second here. So this process is much faster than the traditional FDM printing process. We really excel at our material selection. We have about 12 to 16 resins that we get directly from carbon that range from an elastomeric to a fully rigid part. And that's really what we're seeing is driving a lot of our projects, is that customers are focusing on a specific material and then moving on from there, because we can hit some really unique characteristics and hit some similar material characteristics to injection molding. Move forward for you. So using carbon 3D printing, we really feel that the design of a part is the most important aspect that allows us to use this technology to its full power. We use CAD in our injection molding side, but using the power of SolidWorks and putting a full assembly into one STL file, we can print that entire assembly in one part through carbon DLS instead of printing a bunch of specific parts at a similar time. We also utilize lattice technology to be able to limit part weight and limit material consumption for parts. We find that we can hit a lot of the same stiffness and strength capabilities to parts while vastly minimizing the amount of material needed. And due to our manufacturing process, which I'll get into a little bit later, the less weight of a part actually increases the print speed layer by layer. And so that's something that we've really found carbon DLS excels at, and that's another aspect that traditional FDM printing can't hold up to. Covered this a couple times, but using separate components all together is another huge benefit of the 3D printing world altogether. But again, carbon really excels at it. We're able to limit assembly time and limit the need for many expensive tools. And a new feature that we've been experimenting with a lot in the last year is our texture ability. We're able to create and recreate some really unique textures on the flat surfaces of our parts and curved surfaces, which we're finding, that people usually spend a lot of time and money putting these textures on molds, and we can do 10 iterations of a single texture, flip back and forth, and find exactly what our customer is looking for. Carbon DLS technology does not require molds, obviously, which allows for a lot of really heavily customized parts. In addition to texturing, we can add serial numbers, which allow us to maintain our traceability when we are doing some of our really intensive prototyping jobs. We can have a serial number run through 1,000 different parts, and then once we take that into our quality department, we can maintain traceability and inspect all these parts individually. And I would like to finish up with a case study of a really exciting project that we're working on with Thaddeus Medical Systems. Thaddeus improves patient care with its iCooler, which is an active, smart, cold chain packaging solution. The iCooler delivers reliable transport of temperature-sensitive medical supplies and specimens, such as expensive biological therapies, vaccines, blood, and tissue samples. Part of its resilient construction, the iCooler contains design-patented gyroid lattice structures manufactured with BPI's acceleration station, powered by carbon DLS. Here's two pictures of those gyroid lattice structures that I spoke of. The gyroid lattice components minimize vibration and shock while maximizing airflow in the payload, battery, and sensitive electronic compartments. We found that this exact geometry actually limits a couple different frequencies of vibrations, and we're finding lots of practical uses for that. During prototyping, the Thaddeus team found that the complex lattice was impossible to manufacture with traditional 3D printing methods, and Diversified Plastics was the only supplier to successfully produce gyroid lattice parts. We printed samples with different lattice sizes and material options, and found that this SIL 30 material, which is one of our cache of materials, hit everything that they needed for performance. This cooler will be initially available in 2 sizes and has a substantial market potential. And they're actively in beta testing right now with a couple of various institutions. So these are some examples of parts that we're currently working on or have worked on, and it's really, we really find it's up to a designer's imagination and how to utilize this technology. Additive manufacturing has been around for 20 years, but I really believe we're still scratching the surface on finding all the unique uses for this technology, because we aren't limited by the normal limitations of manufacturing. All right, so I'm going to start my video here and show you guys our acceleration station lab in Diversified Plastics. All right. I'm going to stop sharing as well here too, which should make my screen be bigger. Hello, everybody. All right, so we're in the acceleration station lab here. We kind of have a circular workflow of how we go through the steps to use these carbon 3D printers. First step behind me here is our dispensing station. The resin comes in cartridges. They're either 1-to-1 or 5-to-1 resins, except for one resin that we have. So they have to be dispensed properly through a mixing straw, as you can see here, which throughout the length of the straw, the 2 resins mix together and then form our in-use resin. So we dispense into cassettes. I have one in my printer here already. And so, you can see that. So once this cassette is inside the printer, we lock it in and we add a platform which has an RFID chip in it, which tracks all the information for the actual print. So which is, we find really useful because that information will follow the print in all the different steps of our production. We add our specific geometries and our sliced files to these printers through Wi-Fi. And then, now I have a print ready to go. I can hit the start button. This print, as you can see here, this platform's coming down. It'll take a second for the first layer to start, but as each layer pulls up, resin flows underneath, and then the printer will come back down and grab a second layer. And usually we find prints are in the 1,000 to 3,000 layers. And so a lot of time when we're trying to maximize efficiency, we're trying to limit the height on prints and utilize the full horizontal area of our build platform, which allows us to nest a lot of parts in there. Having one long vertical part is going to be obviously more expensive and less efficient in terms of time and material. And so, yeah, this print will probably go for a couple hours here. And then what I'm going to do right now is I'm going to stop my screen, move my computer to a different location, and show you a print that's in process. Bear with me for 1 second here. All right, so I moved across the lab here. This is another print that we started earlier in the day. And we can see that this platform has elevated off, each of those layers grabbing and adhering to the bottom. And so when this print finishes, we will have it connected to the bottom of one of our platforms. And there will still be liquid resin, uncured liquid resin, covering the bottom of this platform and the entire geometry on the part. And so what we do then is we move to, this is another carbon product, a smart part washer. We'll open this up, place our platform inside. And like I discussed earlier, the RFID chip here holds all the information for the specific wash that we need for the specific geometry from our printer. So I would go here and I would hit a certain wash cycle that we have. We have different wash cycles for different materials and for different geometries. If we have a bunch of really small, thin parts that are just on the top of the platform, it'll be a less rigorous wash than if we have, a large piece of geometry. I'll show you an example of something that we printed just this morning, which is our logo, but printed in a lattice. So again, what I covered in my presentation earlier is, allowing us to make a cool design, but more importantly, limit the amount of material that we need to print something in this shape. This is a rigid, so we find it really still holds up to a lot of the strength requirements based on the actual pattern of our lattice. And so a part would come out of the smart part washer with all of the uncured liquid resin removed from it. And then we bring it over here to another station that we have, which is where we remove all the supports and we finalize the part and get all of the little support structures that we made. If there's an unsupported angle or something that we need to design a support structure so we're not printing on an overhang, we'll remove these in this location. And then we move to our two ovens here. And so all of the carbon one part resins, 1 to 2 part resins, and 5 to 1 part resins are all a two-step cure. So the first cure actually happens in the printer where the light is coming through that oxygen permeable membrane and hardening up the resin. Well, we still consider that to be in the green state. Once we take our parts and put them into the oven, that's when we really see that strength come out, and that's the final cure. And unlike other 3D printing practices, all of those layers that we print layer by layer are actually fusing together on a molecular level. And that's how we can provide, really smooth surfaces, but as well as some really strong end-use parts. So I know I probably breezed through that very quickly, but yeah, that's a very quick overview of kind of our workflow and how we actually produce these parts in carbon DLS. And yeah, at this point, I'd like to open it up to some questions. A little bit.
All right, so again, if you have questions, you can feel free to use the chat function to send questions in. One question I'm curious on, again, coming from an injection molding background, there's always the balance of embracing new technology and being fearful of it. You talked about some technology that replaces some of what you guys do. How do you guys balance that, or how did Diversified make the decision to kind of pull the trigger on something that was kind of scary, maybe?
Yeah, I'll jump into that, Steve. And actually, on one hand, it looks like you're cannibalizing ourselves, and in some ways we are. But point is, we've proven it to be a very complementary addition to our injection molded business. As an example, with the speed that we can bring with carbon DLS, we're in conversations with projects we would have never been if we would have stayed purely with injection molding, given the lead time it takes for tooling and everything else there. The list of applications that AJ showed are just a subset of applications we've had in the last 12 months. And many of those, again, we would not have been in that conversation if we didn't have this technology. So over time, we fully expect additive is going to continue to advance and evolve and take over some of injection's business, but it's better for us to be there now than wait and let it happen that way. So it's proven to be a very complementary addition to our business.
I assume it just opens up additional conversations and opportunities that you wouldn't have seen otherwise. So have you gotten I'm assuming some new customers out of this partnership?
Absolutely. I mean, we've generated each year that we've had it, 2 years now, well over 24 customers each year. Now, admittedly, those are sometimes small, emerging. Many of them are med device companies at this point, but we're starting to, as carbon is becoming more well-known in other OEMs and other segments, it's starting to pull the technology through, and we're starting to get into those repetitive production jobs. And there's a host of product applications where instead of needing hundreds of thousands of parts a year, you need 10,000, 15,000 parts a year on a repetitive basis. And economically, it doesn't make sense to go into a tooling injection molded state. So it definitely has given us opportunity to bring many new customers on. And we've also seen the hinge point where people are saying it's time to go from additive into injection. And we're starting to have those conversations.
So I assume being on kind of the front end of some of the technology and applications, do you have, and you mentioned you've got a lot of newer customers that might have smaller projects. Do you have a lot of front end, work that ends up being very costly, very high engineering content, a lot of wishy-washy customer? I mean, dealing with a lot of, customers that probably haven't figured out their own products yet. Has that been a pain factor, or has it been actually pretty, you've been able to make projects pretty productive?
AJ, do you have a perspective on that? I mean, I do, but you're closer to that than I am.
Yeah, well, we find doing sessions like this and educating people on our process and what we really need out of a specific geometry to make it work is really helpful. And so, we want to bring people up to speed with what we're doing. And there are slight differences that we need in a part versus an injection molding part versus a carbon part. And yeah, just educating people on actually how this process works is really, really beneficial, because then we can ensure that we're providing them with a part that is going to fit their expectations, and then also inform their current injection molding part.
Right. So Steve, just to add on to that. So for years, DPI has been really good at offering design for manufacturability with customers. Since everything we do is custom, we take their design and try to optimize it. We're getting better and better in the design for additive manufacturing, as AJ says. So there's still some upfront investment, but I think as we get better, we can advise customers sooner and better in terms of what is capable. And AJ and his team are doing a great job of that.
This is kind of a curiosity question. I know you guys, are employee owned, which obviously brings in some extra dynamics. do you find that ends up helping as far as, especially with some of the fear factor? You've got probably some, machine operators and tool makers that have been in the industry for a lot of years that might see this as a scary thing. Do you find that being employee owned has helped get those employees more engaged in the innovation and new ideas?
Yeah, that's a good question. And we're very transparent with a lot of things here. We have monthly employee meetings, we share financials, we share new projects, we share key metrics, et cetera. And every month we have an update on Acceleration Station, whether it be we turned an additional printer on or brought in some more equipment, or whether it be a particular project or whatever. And we had a woman who was one of the longest tenured employees at DPI, who volunteered to be one of the first operators in Acceleration Station. So I think that was a great testimony to people willing to support and get engaged in the technology. And then you have someone like AJ who comes in from Dunwoody, who specifically got trained on additive, and it's been a nice mix, not only technology-wise to what we offer, but employee-wise as well. So I think people are very, very interested in it and looking to make sure it succeeds.
Great. How about anything to do with COVID this year? As far as I know, you guys have taken some projects related to COVID. Have they been related to carbon? And have you had any supply chain issues with some of the resins? What challenges or opportunities have you seen?
Yeah, AJ, do you want to provide your perspective on that?
Yeah, we've I think the speed of 3D printing has really come into light with all the different COVID projects that I think everyone's seen around the world, people in their basement making face shields and stuff. And yeah, we did a big push for face shields at the beginning of COVID. We've actually had a lot of ventilator parts and ventilator splitting projects that we've worked through. A couple that are actually in human trials right now. And the speed to market is a huge factor for us. And then when something like a global pandemic happens, we can shift gears and we don't need to wait and make a mold to find a part that can help people. And so yeah, we've been really focused on anything that we can do and trying to partner with correct projects to put parts in people's hands faster. But in terms of material, we haven't had any supply issues with material for carbon itself. But as you can see, I'm wearing PPE in here, which we haven't had any issues. Haven't had any issues getting yet, but that's been a closely watched factor for us. Keep our people here.
And just to enhance one thing AJ mentioned, ventilator splitters. There was a project we were involved in with a major med device company this was back in April when the issues were just huge in New York City. And literally within 2 weeks, we went through 6 design iterations of this splitter with this med device company in order to quickly design it, refine it, and print it, and then be able to use it in hospital in New York City. Something that was absolutely impossible to do in an injection molded world. So that's a great example of how fast you can move with this technology.
Probably helped your employees' morale over that time period too, as a lot of the whole world is trying to figure out what their lives look like. You got employees that are contributing. That's pretty cool.
That and some of the things we were able to do on the injection side. Yeah, I think our employees were excited about being in the fight, if you will, with COVID.
How about, you guys are still, in the scheme of things, you're a pretty small company, compared to some of the big giants that are working on big projects. With new innovation, new technology, world chaos this last year, how do you find or allocate resources? It's not like you just go on Indeed and pull up carbon experts. I'm assuming you get some partnership and support from carbon, but with all these new projects, all the engineering required, how do you guys balance those resources? Yeah,
that's a great question. And carbon is a strong partner, not only in supplying machines and resin and such, but they're out there, as I said earlier, talking to end application customers in multiple industries and trying to pull the technology through. And when that happens, then they connect that end user with a production partner like us. The reality of COVID is that with a lot of the furloughs and layoffs that happened in the March, April, May, June time period, a lot of that was affecting R&D centers, engineering staffs. They were working remotely versus in their centers, and things slowed down considerably in terms of a lot of new projects coming on. But as AJ and I just spoke the other day, in the last, and AJ, you can jump in here, 30 to 60 days, it's just been a rash of new projects coming our way. And most of them are coming from engineering and R&D staffs who have a need to either make it, a design that's really tough to manufacture, or something where they don't see it scaling to the point where you are going to legitimize or rationalize, injection molding, or need some, things like latticing versus, being able to print it in a complete solid state, if you will. But AJ, you're closer to the activity that we've received recently.
Yeah, no, it's been really nice to see a couple of projects that have kind of been on hold because of COVID are starting to come back, and then we're seeing, a huge influx of people inquiring about the technology, and it's almost like the light at the end of the tunnel, for this whole COVID darkness that we've been in, and I think people are finally starting to be confident that there's going to be a normal return to business here in the next, hopefully, a few months, but in a short time period. So yeah, we've seen people be really looking into this technology for a lot of different uses really recently. So we're excited about that.
Yeah, and as AJ said, speed is an important factor. The strength of this product through this technology is important. The availability of resins and continued resins. I mean, we just learned of a new resin that'll be available at the end of March yesterday. And we're currently testing a different, newer resin with carbon right now. So speed is there, but it also talks to product quality. And I think it fits very well in that, whatever small to medium volume means to people, but whatever the volume is where tooling isn't justified, that's a sweet spot for that. And then the last is the difficult to produce parts. And, that lattice structure that AJ shared with Thaddeus, that's a product that's not producible in pretty much any other technology, right? So all those factors combine to the interest that we have seen, and it was very active prior to COVID, slowed down a little bit in COVID, and now it's ramping back up as kind of things start returning to normal.
Good luck with that normal.
Yeah.
Well, again, if anyone has any additional questions, feel free to put them in the chat log now. I'm curious with, again, kind of some innovative uses, and how much leeway has the FDA or other or Department of Defense or other regulatory bodies given to using this new technology in, again, if you're using it for test products, it's one thing, but if you're going to start using it in production, are they pretty tight controlled over that? Have they given a lot of leeway to using this technology?
Well, again, I'll jump in. AJ can speak probably to more specifics, but we just recently had our ISO audit in December, and now our additive area is now part of our ISO certification. So we're really viewing it as a production and integrating into our entire QMS system here, rather than purely as a prototype. We'll still do prototype and concept work and such, but the focus is, especially in the med area, to make sure that we can incorporate that throughout all of our system. AJ, do you want to add to that?
Yeah. So Carbon is really good at getting certifications for most of their materials, or most, if not all of their materials, have either have a safe to come in with human contact or biocompatibility. And so, as we see their new materials be released, usually a few months after that, we start to hear of the different capability testing that they're going through. And yeah, so these resins are meant for production. They're meant for end use parts. A big thing I like to say is we aren't SLA. If you're that was kind of the precursor to carbon DLS is SLA. It's a similar resin style printing with a upside down And that's more for prototyping and for modeling. But when Carbon brought in their oxygen permeable membrane, that really opened up to a lot of these new materials that, yeah, they have technical data and information about all these parts where we can comfortably and safely use them as end use parts.
How about any sterilization restrictions on any of the materials?
We, for our MPU 100, we are able to sterilize, specifics are, I can't remember which ones are specifically, but yes, we have a number of resins that are able to be sterilized under gamma. They're, for each of their kind of resin streams, they have a different set of characteristics that they're going for. So yeah, for their medical grade one, we're able to sterilize, and there's a RPU 70. We're also able to sterilize. So yes.
All right. Well, I don't think we've got any more questions. So unless you guys have anything to add, we can maybe wrap up, and appreciate you guys, the folks at Diversified, AJ and Kevin, being a part of this, and appreciate everyone joining us. This program is recorded, so we'll have it available, and appreciate everyone joining in. And hopefully you guys, if anyone's traveling today, have safe travels. The roads are looking a little iffy now, but and hopefully, as Kevin said, we'll get back to a bit of a normal sometime soon here. So.
Well, Steve, thanks for giving us the opportunity. We appreciate it. Thank you.
All right. Well, thank you everyone again, and take care, and we'll look forward to seeing you in person soon.
Thank you.
Take care.